Hey guys, welcome back to another video from Mrs. Semino. So we're still in this scientific measurement and chemistry unit, but I don't know who's probably happier, me or you. We are on the third and final video. And in this video, we're going to be talking about calculations using significant figures. So before I jump into what's happening here, I just want you to notice that first off, we're going to start off with rules for addition and subtraction. And then in a couple slides, we're going to see that there's rules for multiplication and division. So I just want to point that out there that addition and subtraction share the same rule, multiplication and division share the same rule. And this first one is a little more complicated for addition and subtraction than multiplication and division. So just know that this lesson gets easier. So the idea here is that whether you're doing addition or subtraction, your final answer should be rounded to the least precise value, or I'll sometimes say the smallest common place value in any number in the calculation. So the idea here is, I know this one says addition, but if we look here, do you see how this goes out to the thousands place? But this only goes out to the hundreds place. So the smallest common place value, or the least precise value here, is going to be the thousands and the hundreds. But what's the one they both have in common? They have the hundreds place in common. So the way that this is going to work, you would just add this up like you normally would in your calculator. So you're going to see a lot of times in this lecture, I'm just literally so this is what your calculator is giving you. But then you want to, in this case, notice how we have to round. So I can't have that thousands place there because there's no thousands place in this measurement right here. So you're just going to add it up like you normally would. Then remember how in the last lecture we talked about if the number behind it's a 5 or bigger, then we'll go ahead and round it up. This measurement only goes to the hundreds place, so we're super groovy. Again, if we look over here at subtraction, this first number only goes to the ones place, so that's the smallest common place value that we're going to have for both of these. I know this goes to the hundreds place, but do you see how this one doesn't have any decimal places? So the smallest number that we can have in our final answer is going to be in the ones place. So again, you'll just do some subtraction in your calculator like you normally would. So in this case, you'd come up with 103.75 in your calculator, but like I said, probably 8 times now. The smallest place value you can have is a 1. So I would look here, this 7 is obviously a 5 or bigger. So we'd round this up and this would be 104 for the correct answer. Now what I'm going to suggest is that you, just like we did on the last slide, you just go ahead and you add it up normally. Then you're going to ask yourself, what is the smallest common place value that we have here? And then you'll go ahead and round it if you need to. So go ahead, take a minute, and again, we're noticing, sorry, I'm not sure what happened with my slides. There's a little typo over here, but I'll fix them in a second so that it matches up with your fill in the blank notes. But go ahead, solve these, come back and check your answers in a second. So I hope that was enough time for you to... Okay, I don't know if the video just switched on you, but it switched on me. So sorry, you guys. Okay, so what I did here is these numbers in black, these are what my calculator gave me. These are not my final answers. So like I said, I'm hoping you're plugging these in your calculator, and then now we're gonna go ahead and we're gonna look back at these and see what the final answer would be. So in this case, I'm hoping that you're seeing that this both shares the tenths place. So our answer can only go to the tenths place. So my real answer for this one would be 183.8. This one down here, this one does go to the 10,000ths place, but this only goes to the hundreds place. So my answer can only go to the hundreds place. So this is just going to be 1.90. And this one down here, this one is kind of tricky because do you see how that's not a significant figure there? So the smallest place value we can go to is the tens place. So for this one, we're going to have to change this to 1,110, and that's because this number means we need to round up, so this will change this to that 1 there. Now on this slide, we're using that same rule of that smallest common place value, or using the common least precise value. I'm hoping either of those are making sense to you. But this one is just for subtraction. So just like we did on the last slide, just go ahead, do the subtraction, figure out what your calculator is telling you, and then come back and check your answers. Oh, so write down what your calculator is telling you and then round to the correct number of decimal places. So just like I did before, I just went in the black here, I just wrote down what my calculator answer is. So let's go back and look at these. So if I look at number, I think this is 44 right there, we can see that the tens place is what they have in common. So this would be 23.4. The smallest place value that these guys have in common is the thousands place. So I'm going to want to keep this value here. I look behind it. Do you see how I'm going to need to round up? So this will be 0.002. And this one here, the smallest common place value is the hundreds place. So for this one, this would be 23,500 for that final correct answer. Again, make sure that if you've got any questions, you're writing them down, and I will totally answer them in class. Okay, so now remember I said that the rules for multiplication and division were a little bit different, and I actually find these a little bit easier. So the final answer must have the same number of significant figures as the measurement with the fewest number of significant figures. So what that means is we're going to look at the things that we're multiplying or dividing, and I'm sure if I was a math teacher I'd know the fancy name for them, but basically this 2.5 has got 2 sig figs. This one right here has 4 sig figs. So if we were multiplying this, this would be our calculator answer, but we can only have the fewest number of sig figs. So this one has 2, so our final answer can only have 2. And then again, notice this was a 6 here, so that's why we ended up rounding up. And then it's going to be the same thing with division. So this one's going to be 3 sig figs, and I just want to remind you that a 0 after the decimal place at the end is significant. This one would have 4 sig figs here. So if we were to divide this, again, this would be our calculator answer, but notice how this one has 4 sig figs for our calculator answer. So I'm going to need to change this so it only has 3 sig figs. So I just, in this case, drop the 2, and 0.0466 would be our final answer for this one. So just like we did before, here's a whole page, and we're going to do multiplication. And I just want to remind you, we want to go with the fewest number of sig figs in the numbers that are being multiplied for our final answer. So go ahead, pause this video, solve these problems, and come back and check your answers. So now I just went ahead and over each value, I wrote the number of significant figures that it had. So if we look here at 47, so we want to have only 3 sig figs in our final answer. So for this one, I would go ahead, keep these digits. Notice that it's a 6, so the answer for this one would be 31.3. Down here, I've got 4 sig figs, 2 sig figs, so I can only keep 2 sig figs here. So this one's a little tricky because if you just wrote 10, that's only going to have 1 sig fig. So you have a couple of options here. Remember, you can put that decimal there, and that would give you 2 sig figs because the decimal's indicating that the 1 was your estimated digit, or you could write it like this in scientific notation, and then this would also give you 2 sig figs. Then down here, this one's kind of tricky because notice that 100 only has 1 sig fig. So that means I'm only going to be able to keep this place value in the 10,000s. I had to think for a second. In the 10,000s place value. So I look behind it. This number is a 5. I don't know if you just noticed that I had a little typo here with the 8. I just added it in. It doesn't affect our number. So we look at the 5 here. That means that we're going to need to round up. So our final answer for this one is going to be 20,000. Or if you're like, I really want to put it in scientific notation because I love it, you could have also written it like this. And then finally, guys, we're going to do some division problems. Again, it's the same rule that we had with multiplication and division. We want to go ahead and look at each of the numbers that we're dividing, figure out which one has the fewest number, and then ensure that our final answer has the fewest number of sig figs. So go ahead, solve these problems, pause the video, and come back and check your answers. So if we look at 50 here, we can see that our numbers that we have are 3 and 2. So our final answer here can only have 2 sig figs in it, but you notice that we need to round up because there's that 8, so this is going to make this 8.0. Notice this one, I just was not trying to trick you. It just kind of happened this way. Remember, this does not count as significant. So this would only have 3 sig figs in it. So I'm going to keep these digits here. So this would be 1.81 times 10 to the negative 23rd. And then down here, 12,000 just has 2 sig figs. 3.55 has 3. So I only get to keep 3 sig figs here. So I'm going to keep this. It's going to be 33,800, and that would be my final answer, unless, again, you are dying to write this in scientific notation. So you could go 3.38 times 10 to the 4th. Okay, as always, guys, make sure you're writing down any questions. The next slide, we're going to do some combination practice of both addition, subtraction, multiplication, and division. So here's what I promised you guys. Here's a little self-check. So use this as like a reminder to remind yourself about what the rules are, and then ask any questions you have in class. So go ahead, solve these, pause the video, come back and check your answers. So before we jump into this, I just want to remind you guys that if we've got addition or subtraction, we're looking for the smallest common place value. And then if we're looking for multiplication or division, we're looking for the fewest number of sig figs. So for this one, multiplication, fewest number of sig figs. So this number here has got 3 sig figs. This one has a lot, it has 5. So our final answer can only have 3 sig figs. So the answer for this one should be 0.037. So wait, 8, and then that last 7 should actually turn into an 8 because this 8 is a 5 or bigger. Okay, now number 50 something here. We're doing some addition here. So remember, we want the smallest common place value. So this goes to the tenths, this goes to the thousandths. So our final answer is only going to be able to go to the tenths place. So this will be 5.3. Subtraction, again, the smallest common place value. So this goes to the thousands place. This goes to the 10,000s place. So the smallest one they have in common is this thousands place. So I'm going to make this 0.068. And then down here, we've got division. So we're looking for that fewest number of sig figs. So this one actually has 4. Don't forget this last guy is significant. This one then has 5. These zeros are significant in here because they're sandwiched. So we can only have 4 sig figs. So our final answer for this one would be 21.87. Okay, guys, I hope this video was helpful. Make sure that you're answering questions. And like I said last time, we'll be doing a lot more practice in class so that you can get more awesome at this. See you soon.